All right, y'all, now we're going on to note card 17, which is called the product rule. Okay, very important rule. Before we actually get to it, I just want to review one of the other rules with you. So let's say, for instance, let's say that, I don't know, h of x equals f of x plus g of x. When there's a plus separating terms, or it could be a minus even, if you were going to take the derivative, if you wanted to find the derivative here, okay, you would just take the derivative of each term and go from there. And likewise, if this was a minus sign, if that was a minus sign, then that would be a minus sign there as well. Okay, so a practical example of that is, let's say that h of x equals 3x squared let's do plus 5x to the third power. When there's a plus or a minus separating those things, you just take the derivatives of the individual terms. So you would do the derivative of 3x squared, so 3 times 2 is 6, reduce the power by 1. So it's just x the first. Then you would keep the sign the same, plus, and then you do the derivative of this term. 5 times 3 is 15, reduce the power by 1. Okay. So fairly straightforward. And if it was a minus sign there, then that would also be a minus sign. Okay. But when this turns into a product, okay, let's say it was a product instead. Let's say that h of x equaled f of x times g of x. Okay. You can't do the same thing. It's not that easy. You don't just take the derivative of this times the derivative of this. We have to use, since this is a product, since the function is a product of two things, what we're going to learn today is what's called the product rule. We have to use the product rule. And let me just tell you what that says. To find the derivative, here's what you do. You take the derivative of the first term, so you would call that f prime of x, times the second term, not the derivative of the second term, but just the second term, plus the first term times the derivative of the second term. Okay, so it's derivative of first times second plus the first times the derivative of the second. Okay? So some people write that like this, like in the note card itself, it says to find the derivative of a product. If the product is u times v, okay, the derivative of that would be u prime, the derivative of the first times the second, so u prime v, plus, it's always a plus, the first u times the derivative of the second. Okay, and it doesn't really matter which one of these you do first. You could rearrange those. You could say u v prime plus u prime v. Doesn't matter which order it's in. Okay. Basically, all I did is just rearrange the order. We know addition is commutative, so you can rearrange the order. Not a big deal. Okay. So let's look at these problems. It says, number 1, find y prime if y equals 6x sine of x. So here, there's an understood multiplication between the 6x and the sine of x. So what I'm going to do is I'm going to treat the 6x as the first term of the product, and I'm going to treat the sine of x as the second term of the product. So to find y prime, to find the derivative, I'm going to take the derivative of the first, okay? The derivative of the first term would be 6 times the second term. Well, the second term is sine of x. Then it's always a plus the first term, which is the entire 6x, times the derivative of the second. What's the derivative of sine of x? Hopefully you remember that's simply the cosine of x. So that's what the derivative function would be. Now, if that answer doesn't show up, there might be some factoring. You notice both of these terms have a 6 in common, so you could take a 6 out. Okay, so you could say 6 times the quantity sine of x, take that 6 out, and you're left with x times the cosine of x. Okay, so it could be written like that as well. All right, let's try another one. So here you have two terms again. I'm going to treat that as my first term, and this is my second term, and they're getting multiplied. So that's the key to use the product rule. Okay, so when I write this down, if I want to find g prime of x, I'm going to take the derivative of the first term. Well, the first term is this entire thing. So I'm going to do -2, that's a coefficient, it stays, times the derivative of cosine, which is negative sine of x. So this whole thing right here is just the derivative of the first term. Okay. But I need to multiply the derivative of the first term times the entire second term. Okay. There's always a plus. Plus the entire first term, so -2 cosine of x, times the derivative of the second term. So the derivative of all of this. 3 times 3 is 9, reduce the power by 1, so 9x squared. The derivative of -5x is simply -5. The derivative of the constant would be 0. I don't need to write in the plus 0. So that would be the derivative. Okay? Or if you wanted to make it a little bit nicer, okay? Here you're adding a negative, so that's really the same thing as subtracting, so I don't need to put that in there. All right, you could factor out either a 2 or you could factor out a -2. Doesn't really matter. Okay? So let's say you factored out a -2. If you factored out a -2, you would have a negative sine of x times the 3x cubed minus 5x plus 7. You factor out that -2, it comes out. Okay, so there's a positive left because you've taken out a negative. Okay, a cosine of x times 9x squared minus 5. So you could write it like that as well. And just realize that this term and this term could switch places because addition is commutative. Okay, let's try one that's a little bit harder because it gives me information in a table. So in the table below, it tells me r of x and t of x are differentiable functions, which means you can take the derivatives of them. Find the equation for the tangent line. Okay, so equation of tangent line at x equals -3. So what do we need for the equation of any line? We need a point and we need a slope. Okay. So the x value of the point is -3. So what I'm still missing, I'm missing the y value and I'm missing the slope. So how am I going to find the y value? Okay. So I'm trying to find the tangent to q of x. Well, it tells me an equation for q of x function. So to find the point on the function q, I would need to take q of -3. Okay. So what does the function tell me to do? Q of x equals r of x times t of x. So I would have to find r of -3 times t of -3. It has nothing to do with the derivative yet. I'm just finding the y value. Okay, so in my table, r of -3 is -4. Okay, and t of -3 is 2. Okay, so -4 times 2 is -8. So what I just found is I found that this y value is -8. Okay. Now I need to find the slope. Well, what's the slope going to be equal to? It's going to be equal to the derivative of q evaluated at -3. But before I can find q prime of -3, I have to figure out what q prime of x equals. So I have to use my rules. What do you notice about q of x? Q of x is a product. So I have to use the product rule. So I would take the derivative of the first term. The first term is r of x, so its derivative is r prime of x, times the second term, which is t of x, always a plus, the first, r of x, times the derivative of the second, so t prime of x. Okay, so to figure out what the actual value is, q prime of -3, everywhere I see a x, I'm going to plug in a -3. Now I can use the table to find this. What is r prime of -3? Here's the r prime of -3 is -2. Okay. Times t of -3, that's +2. Plus r of -3, that's -4. Okay. T prime of -3, that's +3. -2 times 2 is -4. -4 times 3 is -12. -4 plus -12 is -16. So I just figured out what the slope is of the tangent line. Once I know these two things, I can write the equation of the tangent line. Y minus -8, coming from that, equals the slope, -16, x minus -3, the -3 coming from that. You got two negatives next to each other here, that turns into a plus. You got two negatives here, that turns into a plus. And this is the equation of my tangent line. So a lot of work in that problem. So you had to find the y value by plugging in the x value to the function itself. You had to take a derivative using the product rule, then plug in the right numbers from the table. That gets you the slope. And then you had to know how to find the equation of a line. Again, this is called point slope form. And you could move stuff around. You could turn it into slope intercept form. So now let's work on example 4. It says find the values of x from 0 to 2 pi, so some sort of angle measure, where the tangent line to the graph is horizontal. So the first thing I'm thinking when I see that, when the tangent line's horizontal, I'm thinking the derivative has to equal 0. That's like the key to this problem. All right, so what's y? Here's what y is. Notice it's a product. So we have to use the product rule to find the derivative. So here's the first term, sine of x is the first term, cosine of x is the second term. So we do the derivative of the first, so what's derivative of sine? Hopefully you say it's cosine. Okay, so that's the derivative of the first term times the second term. All right. Plus the first term is sine of x, times the derivative of cosine. Derivative of cosine is negative sine. So if I simplify this a little bit, I get cosine squared of x. And here I'll get sine squared, but there's a negative. So minus sine squared of x. Okay, so that's what the derivative function is. I need to figure out where is the derivative equal to 0. So I'm going to take this and I'm going to set it equal to 0. Doesn't really matter how you do this. So let's just add sine squared on both sides. So cosine squared would equal sine squared. Okay. How do we simplify this? Okay, take the square root of both sides. So when I do that, I get absolute value of cosine of x equals the absolute value of sine of x. Which really means, where does the cosine of x equal plus or minus sine of x? So think about this. Think about the unit circle. At what angle measurements do cosine and sine have the same values, but without regard to pluses or minuses? Okay. So if I think about it on the unit circle, kind of going back to my unit circle idea here. All right. On my unit circle, here at 45 degrees, you know that both of the numbers are square root of 2 over 2. Okay, here at 135 degrees, they're both square root of 2 over 2, but the cosine value is negative because you're in the second quadrant. And down here, they're both negative square root of 2 over 2. Okay. And down here, well, this angle was 180 plus 45, so 225. This one's 45 less than 360, so 315 degrees. And here you have square root of 2 over 2, comma, negative square root of 2 over 2. So at every 45 degree reference angle, the values are square root of 2's over 2's. Now sometimes they have the same sign, sometimes cosine and sine are both positive, and sometimes they have opposite signs. But I don't care about the signs because I just want to know where the numbers equal each other without regard to the pluses or minuses, because there's really absolute values here. So I have 4 angles. Okay, I have 4 angles that work. I have 45 degrees, I have 135 degrees, I have 225 degrees, and I have 315 degrees. But wait a second, this is calculus. We're not allowed to use degrees, so we have to know what these are in radians. Okay. Well, remember, pi is like 180. How do I get to 45? I take 180 and divide it by 4. This number is 3 times greater than that, so that answer is 3 pi over 4. Okay. Well, to get 180 is pi, so if you do pi plus 45, 180 plus 45 gets me to 225. So pi plus pi over 4 is like 5 pi over 4. Okay. And this is 7 pi over 4. So these are all the x values in radians. We always want answers in radians. Let's make sure. Okay. Let's just graph that. So what I'm going to do here, I'm in radian mode, which I need to be in, because that's what we use in calculus. Okay. So I'm just going to type in the original function, sine of x times the cosine of x. All right. And I only want to look at this from 0 to 2 pi. The question is, where is there going to be a horizontal tangent line? To me, it looks like there's one right there, one right there, one right there, one right there. Looks like there's 4 of them. Okay, let's just check the x values we got. I'm just going to hit trace. If I type in pi over 4, there's the first one. There would be a horizontal tangent right there. Okay, the next one, 3 pi over 4, I think that's going to be this one. There you go, you're at the bottom of the curve there. It's pretty obvious. And then you can try 5 pi over 4. You're at the top of that curve. And then you can look at 7 pi over 4 should be this one. And there we go. So the calculator confirmed our answer for us. Hopefully you don't have to use the calculator on this question. That's the goal. All right. A few more practice here. All right, so in the class notes, more notes here. I want to find the derivative of that entire thing. Well, 5x cubed is the first term. That's being multiplied times sine of x. So I got to use product rule, because that's the product. Okay, so I would say y prime equals, or you could say f prime, I don't really care what you call it, the derivative of the first term. What's the derivative of 5x cubed? It's 15x squared times the second term all by itself, always a plus, the first term by itself, times the derivative of the second. Derivative of sine is cosine. Okay. So you could leave the answer like that, or you could do some factoring. And what do they have in common? They both have a 5x squared in common. And so if you factor out a 5x squared, 5 goes into 15 3 times. You already got the x squared taken care of, so 3 sine of x. Okay, you got 5x squared taken care of. There's still another x, so plus x cosine of x. Okay, so that would be an acceptable answer. Or you could just simply flip-flop those two. Okay. So number 2 says, given that m of x, p of x, and h of x are all differentiable functions, they give me some values of the functions and the derivatives. I want to find the slope of the tangent line to m of x at x equals -3 if m of x equals this. So I'm just looking for the slope of the tangent line. What does that mean? Derivative. Which function do we care about? M. So what I'm really looking for is m prime at an x value of -3. This is what I'm trying to find. That's the only thing the question asked me to find. So before I can find m prime of -3, I first have to find m prime of x. Okay, so here's my first term, -2h of x. Here's my second term, p of x. Those are being multiplied, so it's a product, so I have to use the product rule for the derivative. Okay. So I'm going to do, what's the derivative of this part of the first term? Well, the coefficient stays, times the derivative of h, which would be h prime. So this entire thing is the derivative of the first term. We multiply that times the second term by itself. Okay. Always a plus. The first term by itself, -2h of x, times the derivative of the second term, which would be called p prime of x. Now, before we start plugging in numbers, if you wanted to make life a little bit simpler, both of these things have a -2, so I could just go ahead and pull out that -2. Then I could just say h prime of x, p of x. I already take out that -2, so plus h of x, p prime of x. Maybe the numbers will get easier after that. But I want to know m prime of -3, so everywhere I see an x, I'm going to plug in a -3. I'm going to use the given information to help me find these things. So h prime of -3, it tells me that's -2/3. Okay. P of -3, okay, that's 4. Just got to find the right information. Plus h of -3 is 2. And p prime of -3 is 1/5. Now, if this was a free response question, leave the answer like this. There's no reason to simplify it. But if this is a multiple choice question, that answer is not going to be there. Okay? If this is free response, leave it like this. If you simplify and simplify wrong, you lose points. Okay? But if it's let's just practice actually simplifying it in case this is a multiple choice type question. Okay? So if I take negative 2 thirds times 4 over 1, that's negative 8 thirds. If I do 2 over 1 times 1/5, that's going to be 1/5, or 2/5, excuse me. All right. Well, we need a common denominator here. All right, so I'm going to go times 5 times 5 times 3 times 3. Negative 8 times 5 is negative 40 over 15. 2 times 3 is 6. Five times 3 is 15. So that's negative 2. Negative 40 plus 6 is negative 34. And negative 2 times negative 34 is positive 68. So positive 68 over 15, that would be the slope. That would be the slope of the tangent line. All right, a few more review problems here. Find the instantaneous rate of change. What does that mean? That means derivative. Okay. So what's my original function? S of t. So I'd be looking for s prime. And it gives me a time value. That's like an x value. So I'm trying to find s prime of negative pi halves. That's what I'm trying to find. Hardest part about calculus is just trying to figure out what they're looking for. So, first step, before I can find s prime of that value, I need to find s prime of t. Derivative of 4t squared. Well, first off, there's minuses and pluses, so I'm just going to take the derivative of each piece. This is not a product rule. 4 times 2 is 8, so 8t. Minus 2, that's a coefficient, it stays. The derivative of sine is cosine. Okay. Derivative of a constant, remember pi is a constant, it's 3.14. The derivative there would be 0. Okay. So I could put in the plus 0, but I don't have to. So I'm trying to find s prime of negative pi halves, which is like pi halves is like 90 degrees. So this is like negative 90 degrees on the unit circle. Okay. So 8 times t itself, well, that's just negative pi over 2, minus 2 times the cosine of negative pi over 2. Everywhere I see a t, I'm just plugging in negative pi halves. Well, 8 times negative pi is negative 8 pi, divided by 2 is negative 4 pi. Minus 2, and think about the cosine of negative 90. Negative 90 is down here on the unit circle. Okay. If you think about that point, it's 0, negative 1 on the unit circle. That's the cosine value. It's 0. Okay. Negative 2 times 0 is simply 0. So my answer here is negative 4 pi. Here was the derivative function when I plugged in negative pi halves. That's what came out. Okay. And one more review problem. Equation of the tangent line. So I need two things. I need point and I need slope. They give me an x value right there. So I need to figure out the y value and I need to figure out the slope. Well, what would the slope be? The slope would be the derivative evaluated at that x value. So I need to find those two things. Okay. So first thing, I'm going to find the y value of the point just by plugging in pi to the function. 3 times pi minus 2 times the cosine of pi. think about the unit circle, pi radians is 180 degrees, so you're right over here. The point on the unit circle is -1, 0. The cosine is like the x value. So it's -1. Cosine of pi radians is -1. Okay. -2 times -1 is +2. So this whole thing right here, that's the y value. Okay. That's the y value. That's the entire y value. Okay. 3 times 3.14 plus 2. Now, I need to find g prime of pi. Before I can find g prime of pi, I need to find g prime of x. Here was g of x. I need to know how to take the derivative. There's a minus sign in between, so I'm going to take the derivative of each piece. So the derivative of 3x is just 3. -2 is a coefficient, it stays. The derivative of cosine is negative sign. Okay. So if I have -2 times negative sign, that's +2 sign. So that's what g prime of x is. Now let's figure out what g prime evaluated at pi is. So 3 plus 2 sine of pi. Well, here's pi radians, here's the sine value, it's 0. 2 times nothing, still nothing. So g prime of pi equals 3. So that's the slope. So here, my point is pi, comma, 3 pi plus 2. Just leave it in exact terms. And the slope is simply 3. Now I can write the equation of the tangent line. Y minus the y value, the entire y value, so I'm just going to keep that in parentheses, that's the entire y value, equals the slope times the quantity x minus the x value of the point. And you can leave it just like that, because that's in point slope form. That's the equation of the tangent line. And that is going to wrap it up for this note card. Let's check if there's a packet. Nope, there's no packet for this note card. Just get really, really good at using the product rule. You'll get more practice in the next note card as well, and in the next packet that you do. So that'll cover this one. And again, this was note card 17, the product rule.